Hi, this is Ms. Fitzmaurice, and this video is a solution to page 10, 2D kinematics problem in your Unit 2 packet. Okay, so this problem says that a group of lemmings run off a 40-meter cliff. So in drawing the picture, we know that they're running straight off. Okay, so their initial velocity is in the side-to-side or x direction. And we want to know, it says E, but first of all, how long is it going to take them to get down to the ocean below? Okay, as with all of these problems, the first thing we want to do is we want to go ahead and make two lists of variables. Okay, X and Y, side to side, and up and down. Okay, so we have X naught X, XX, V naught X, AX, VX, sorry, AX, and then T in the middle. Likewise, we have X naught Y, XY, V naught Y, VY, and AY. And we're going to go ahead and try to fill these in. We know that we can start our initial X position as X naught X equals 0. XX we don't know. V naught X we are also not given in the problem. Okay. VX also not given, but we know that AX is equal to 0. Okay, so these little guys are running off the cliff. We know that at the beginning, all of their velocity is in the side-to-side direction. It's all horizontal. So V naught X is 0. Okay, because they are not moving up and down at the beginning. We know that gravity gives us AY, and that's -10. VY, we don't know. XY, okay, the final height, XY, that should be a Y, that's 0, because their final height is 0. And X naught Y, their initial height, is 40. Okay, so looking at these two, we have more information in the Y direction. That means we can go ahead and find time in that direction. Okay, we can use our first equation. So I'm going to go ahead and use XY equals X naught Y plus V naught Y T plus 1/2 AY T squared. Okay, then we're going to go ahead and fill things in. So we have XY is 0, X naught Y is 40, V naught Y was 0, so that's going to go away. So we have 40 plus 0 plus 1/2 AY is -10 T squared. Okay, and I'm going to go ahead, do some algebra, and solve for T. I end up with T is equal to, and it'll be 40 divided by 5. So T squared is equal to 8. And T is equal to about 2.83 seconds. Okay, and by the way, if you haven't actually tried this already, I should have said this at the beginning, but you should try this problem before you go ahead and get the answer. Okay, so we have T is equal to 2.83 seconds. Okay, and in the second part, I'm going to get rid of this. Okay, in the second part, we want to know if the lemmings land 10.1 meters from the cliff. So xx is equal to 10.1 meters, how fast were they going as they ran off? Okay, so we're going to get rid of this question mark right here and put a 10.1. So that's still 0, and we have 10.1. Okay, and what we're looking for is v naught x. Okay, so now we have the benefit of time, and we can use the first equation, but in the x direction. So we have xx equals x naught x plus v naught x times t plus 1/2 axt squared. Okay, we know that x naught x is 0, and ax is also 0, so I end up with 10.1 is equal to v naught x times 2.83. I'm going to divide both sides by 2.83, and I end up with v naught x is equal to about 3.53 meters per second. Okay, so that was part B. In the third part, so I'm going to go ahead and get rid of that and put in 3.53. In the third part, it asks us to sketch a graph of the horizontal position of the lemmings versus time. Okay, so I'm going to go ahead and flip to a new page. And we want horizontal position, so that's xx versus time. Okay, and I'm going to be going back and forth between the pages. Because our acceleration is equal to 0, we know that we don't have a parabola, instead we have a straight line. Okay, because we start at 0, our graph is going to be at 0, and our slope should be 3.53. So I'm just going to start at 0, straight line up, and I'm going to write slope equals 3.53 meters per second. Alright, next it asks me to sketch the graph of vertical position of the lemming versus time. Okay, so, oh, by the way, I should have said this is linear, because I asked what type of graph. Since a equals 0, xx equals v naught x t. Actually, since a equals 0 and xx equals 0, this is our function. Okay, our next part asks us to draw vertical velocity with, or vertical position with time. Okay, so I'm going to go and look back. Okay, you notice that I start out at 40 meters, and then I end up at 0 meters. Okay, so, by the way, this is in meters, and this is in seconds. I should have put that, seconds, meters. Okay, and I'm starting out at 40, and I'm going down to 0, and the time is not 0, but the position is 0. So I have a graph that hits these 2 points. Okay, because I have a negative acceleration, my graph should roughly look like a parabola, because there is acceleration, and it should look like a sad-faced parabola. Okay, so sad-faced parabola with negative acceleration. Okay, in the next part, it asks us to sketch a graph of horizontal velocity of the lemmings versus time. So we have Vx, this is in meters per second, and time, this is in seconds. Okay, since a equals 0, Vx equals v naught x plus at, and basically Vx equals v naught x, which is a constant, okay, so I should get a graph that looks like this, and the height of this graph, which maybe I'll put on the side, is our initial x velocity, which was 3.53 meters per second. Okay, the next thing it wants me to do, and the last thing, is it wants you to sketch Vy versus t. Okay, and it's asking you, A, what kind of graph does it make, and how do you know? And actually, this one I'm going to have to make a negative. Okay, so we know that we start out with a y velocity of 0. Acceleration is constant but negative, so we should have a negative slope. And our graph should look something like this. Okay, so since ay is negative, Vy equals v naught y plus ay t. Our v naught y is going to go away, and Vy equals ay t. Negative a means negative slope. Okay, because in terms of math, here Vy is playing the role of my y, my vertical on this graph. Ay is my m, t is my x. So like y equals mx plus b, and our b is equal to 0. Okay, so just to summarize again, this was a constant function, or you could say linear. This is linear with negative slope. And I wrote the negative slope, so I'm not going to write it again. Okay, I hope this was helpful in terms of reminding you how to do both position time graphs, velocity time graphs, and 2D motion.